the opposite, the opposite to its own movement, in order to bring an object 24 hours back to where it was. And the second part of my question, looking at the history of Earth and different theories where the scientists say that the planet Earth was going through different cycles of life and different, degrees of human, wisdom, is it possible that we are, as in our present time, one of the, cycles or one of the, levels? And
all right, we're going to, we're going to have to leave it there. I think Dr. Kaku knows what you're looking at.
Okay, you talk about how fast our rockets go, and can our rockets actually synchronize themselves with regards to the planet Earth and even move faster than the planet Earth? And the answer is yes. A typical rocket travels at 18,000 miles per hour. That's the orbiting velocity sufficient to go around the planet Earth. And our rockets can actually go faster than that, 25,000 miles per hour. That is enough to take you to the moon. In fact, it was Isaac Newton who was, in principle, the first man capable of calculating what it would take to jump to the moon. If you can run 25,000 miles per hour and jump, you too could jump all the way to the moon. And then, to answer your question about synchronizing with regards to the Earth, we also have satellites that are geosynchronous. They go around the Earth in 24 hours. The Earth itself spins in 24 hours. Therefore, we have the illusion that the geosynchronous satellite is actually stationary. So when you plant your TV dish and you lock onto a satellite, that satellite doesn't fall down. It's actually spinning around the Earth, but at a very large distance, about 22,000 miles. So given the fact that our missiles and our rockets can travel, let's say, up to 30,000 miles without too much effort, it means that, yes, we can definitely synchronize ourselves with regards to the Earth and its planetary motion.
Greensboro, North Carolina. Hi, Lori.
Yes, hi, how are you?
Good.
Hi, Dr. Kaku. I have a question about emotional vibration or energy in motion. And it stems from a person I know, Riley Martin, and he wrote the book Coming of Tan, and he notes that beings whose home planet is not Earth, that they're actually intrigued by the emotional energy of humans and humans' ability to feel and emote and vibrate that energy with love and heart. So my question was, how and what do you feel about emotional vibration, that energy, and its impact on humanity's consciousness, the planet's vibrational field, and the multiverse's vibrational field?
Okay, you ask an awful lot, so let's try to break it down one by one. First, you talk about vibrations. Everything is vibrating? The answer is yes. Everything is governed by tiny little waves. We have equations for these waves given by Erwin Schrödinger in 1925, and that's the beginning of wave mechanics, out of which transistors, lasers, GPS systems, satellite operate. So first, everything is vibrating, just like what people say. Second, there is such a thing as emotional energy, and scientists are now beginning to appreciate more and more the power of this emotional energy. While before we would say, ha, humbug, that's like soft-headed science, now people are realizing that it's very important for us to communicate for our well-being. Emotions affect the body in ways that we are just now appreciating. And also, if you watch science fiction now, you watch Star Trek and we have Data. Data, the robot, has no emotions. And we say to ourselves, well, gee, emotions must be a very high form of intelligence. Well, now we realize how important emotions are. A stroke victim, for example, will sometimes have the front part of their reasoning brain disconnect from the center part of their brain, which governs emotions. The center part of our brain, the limbic system, is the emotional brain. The front part is the cerebral cortex, the thinking part of the brain. Stroke victims, accident victims, sometimes the connection is broken. So what happens when people have reasoning ability but no emotional control? What happens is, and this shocked scientists when it was analyzed, these people have problems making decisions. They're paralyzed because value judgments, what's important, what's not important, what is precious, what is not precious, what is irrelevant, it's all the same to them. When they go shopping, they're paralyzed because everything's the same to them. What's important, what's not important. And so now we begin to realize why emotions are important for our own evolution. We would be paralyzed. We wouldn't know what's important, what do we have to do. Everything's the same. So emotions give us an emotional value judgment on certain kinds of behaviors. That's how we decide what is important, what is not important, what is precious, what is not precious. And that's why Data and Spock on Star Trek, they're making emotional judgments all the time, even though they're supposed to be not emotional. They made the decision to join Starfleet. They made the decision to do this, to do this. All of them are value judgments. So scientists now are beginning to appreciate the importance of emotions in designing artificial intelligence. It's part and parcel of that. But as far as energy fields and stuff like that go, we think the brain does emit energy, and this energy is electromagnetic, and you can measure this with EEG scans, MRI scans. But you cannot manipulate objects without external intervention. We can now, quote, read these emotions with MRI machines and EEG machines, but it takes machines to do this. With brainwaves, we can now actually tell what you are thinking about to a degree. This is a fast-moving field. It's called mental imaging. We're now capable of actually imaging some emotions of the brain using our instruments. But again, this is a frontier area, and it's an area that is not explored very much at all, because scientists historically would poo-poo this whole area, which we now know to be very essential to creating intelligent people.
And in Physics of the Impossible, you write about these things, and you write about categories of impossible technologies. Class 1, those that are impossible today but do not violate the known laws of physics. Class 2, those that sit at the very edge of our understanding of the physical world. If they are possible at all, they might be realized thousands to millions of years in the future. And Class 3, those that violate the known laws of physics. Is there any technology today that exists that's now used to be Class 3?
Take a look at invisibility. I used to teach in my optics course that objects cannot be made invisible because the index of refraction is always less than 1. We would write that equation on the blackboard, say QED, ergo, no such thing as invisibility. Well, we were wrong. I was wrong. Every single optics textbook on the planet Earth is wrong in saying that invisibility is a Class 3 impossibility. Just 3 years ago, we did it with microwave radiation. It turns out that you can build a cylinder like a Harry Potter cloak. Microwaves will hit the cylinder, wrap around the cylinder, come out the other end as if you are not there at all. With light, we think you can also do it with light beams now. In Germany, they actually made a small particle disappear optically. So in the future, we may have an invisibility cloak. Light will come at you, light will bend around Harry Potter, reform on the other side of Harry Potter, and Harry Potter inside this cloak becomes invisible. Just like a boulder in a stream. If you're downstream of a boulder, you don't know there's a boulder upstream because there's water wrapped around the boulder and reformed. Well, we've done it in the laboratory. The index of refraction can actually be negative. We never thought that was possible because there was a loophole in the laws of optics. We always assumed that materials like glass are uniform. Once you make them highly non-uniform, you create what are called metamaterials, and bingo, objects can become invisible. So something that was Class 3 now becomes something called Class 1.
Dr. Kaku, email from Terry Nichols, Glastonbury, Connecticut. One often sees photographs of theoretical physicists standing at blackboards filled with mathematical characters. Is math the only language through which the complexities of physical reality can be expressed?
Yes and no. First of all, when we physicists talk to each other and write papers, it is in the language of mathematics. However, beyond the math is the physical picture. It is the picture that makes everything move. My favorite Einstein quote is, quote, "If a theory cannot be explained to a child, then the theory is probably worthless." Meaning that all great theories are explained pictorially. Newton thought about apples and balls going around other balls. Einstein thought about trains and rockets and clocks and meter sticks. String theory talks about little tiny vibrating rubber bands. All these things are pictorial, things that children can understand. I've noticed that some scientists who are not so good get trapped in the thicket of mathematics. They get mired down in the quicksand of all this algebra, and they lost the picture. That, unfortunately, is what happened to Einstein in the last 30 years of his life. He was onto an idea, but there was no picture there. So he worked on the unified field theory for 30 years, but there was no guiding light. He was looking for, he wrote the fact that I have no guiding principle. I know the destination is unification, but there's no shining light that led him to relativity, no shining light to the unified field theory. So math is important, but what's more important than the math is the physical picture behind the mathematics. Now the other thing is, yeah, you have to have mathematics. It's like trying to learn French civilization without learning the French language. Sure, you can get a comic book understanding of French history and the French character, but to really understand the French civilization, you have to learn French. So that's something that is essential. You do have to pay your dues. You have to learn the math.
Next call for Dr. Kaku comes from New Mexico. Christmas, New Mexico, Ryan. Hi.
Hello, yes, thank you, Doctor. It's good to talk to you. Calling from Las Cruces, New Mexico. I was a New Mexico State University physics major, but then I left to the Navy and I came back, and now I'm returning back to school. And you may have heard of Sandia Lab and Los Alamos Lab. They're known for New Mexico and the birthplace, I believe, of the atomic bomb. I know we're time limited, so I'm just going to get to the point. If you could do it all over again, you go back to school, would you have gotten a math degree? You know, we noticed that math is very, the language of science, but they talk about complex analysis, they talk about number theory, and it's used in physics and chemistry. But would you go back and do math instead of physics?
When I was undergraduate at Harvard, I was looking into different things, like maybe even philosophy or mathematics, but I began to realize something that was very unsatisfying. And that is that in mathematics, you could get lost because there's no guiding principle, there's no physical hint, there's no application. And as a consequence, you can spend all your time doing proof theory or going around in circles and not being relevant to anything at all. You spend all your time trying to prove theorems which are kind of obvious but are very difficult to prove. Arthur Eddington, the great cosmologist, once said that mathematicians engage in self-flagellation at the altar of proof. Now think about that. Here's an altar, there's proof. You want to prove this theorem, and you spend the rest of your life flagellating yourself trying to prove this obscure theorem that no one cares about. I said to myself, that's not for me. I want to explain creation, Genesis, the way the universe evolved, the superforce that drives everything forward. So I took a course in philosophy. I thought maybe in philosophy we'll have deeper understanding of the nature of reality. Well, we spent like one whole semester on Aristotle, learning things that are totally of no relevance at all. I read the Nicomachean Ethics about what is the good, and after reading this gigantic textbook written by Aristotle 2,000 years ago, the good turned out to be the mean. Not too close, not too far, the mean, that is the good. So I began to realize that there was something unsatisfying in philosophy, that it was detached from reality. And Einstein even said that philosophy is like honey. It looks good, it smells good, but after you touch it, you realize that it's all gooey and messy and not really relevant at all. In physics, I saw things that are fundamental to reality. And being a physicist, I understand how DNA works. I understand how computer architectures might work. I can begin to understand other areas of science, because physics is the foundation of all science. And so being a physicist is very easy for me to look into other areas outside physics, which are byproducts of physics. The DNA molecule was unraveled by physicists. Francis Crick was a physicist. Delbruck, many of the early pioneers in DNA research, they were all physicists. People working in artificial intelligence theory, many of them are physicists. And if you take a look at the great inventions of the world, they're all invented by physicists. Lasers, television, radio, microwaves, MRI scans, PET scans, you name it. Some physicists created it. And so I said to myself, that's for me.
Rick, Flag